This video covers Section 4, State Types. Finite state machines can express an algorithm as a number of states, their relationships, and their input and output. Remember, states are elements in your state machine. Individual states can make decisions based on their input, perform actions, and pass output to other states. States can perform a variety of functions in your state machine. A task state does some work in your state machine. A choice state makes a choice of which branch to run. A fail or succeed state stops running a state with a failure or success. A pass state passes its input to its output or injects fixed data. A wait state provides a delay for a certain amount of time or until a specified time and date. A parallel state begins running parallel branches. Finally, a map state dynamically iterates steps. In this section, we'll take a closer look at each of these state types. Tasks do all of the work in your state machine. A task performs work by using an activity or a Lambda function, or by passing parameters to the API actions of other services. The Amazon States language represents tasks by setting a state's type to task. It also provides the task with the Amazon resource name, or ARN, of the activity or Lambda function. An activity consists of program code that waits for an operator to perform an action or provide input. You can host activities on Amazon Elastic Compute Cloud or Amazon EC2, Amazon Elastic Container Service, also known as Amazon ECS, or even mobile devices. Activities pull step functions by using the getActivity task, sendTaskSuccess, sendTaskFailure, and sendTaskHeartbeat API actions. Step functions can invoke Lambda functions directly from a task state. Step functions also integrates with some AWS services, including the ability to directly call and pass parameters to the API of those services. You can use step functions to coordinate these services directly from the Amazon States language. This slide shows two examples of the task state. The first example performs an activity named Hello World, which is identified by the activity ARN in the resource field. The second example performs a Lambda function, which is identified by the Lambda function ARN. A choice state adds branching logic to a state machine. A choice state must have a choices field whose value is a non-empty array and whose element is an object called a choice rule. A choice rule contains a comparison and a next field. A comparison is two fields that specify an input variable to be compared, the type of comparison, and the value to compare the variable to. The next field value must match a state name in the state machine. In the example, the first choice rule checks whether the numerical value is equal to 1. The second choice rule checks whether the numerical value is equal to 2. Note the $ symbol in these examples indicates a variable. You might see this in the other state examples. This slide provides examples of a succeed state and a fail state. A fail state stops running the state machine and marks it as a failure. This state requires the type field to specify the state's type. In addition, the fail state offers two optional fields, the cause field and the error field. The cause field provides a custom failure string that can be used for operational or diagnostic purposes. The error field provides an error name that can be used for error handling, operational, or diagnostic purposes. Because fail states always exit the state machine, they don't have a next field and don't require an end field. A succeed state stops running a state successfully. This state is a useful target for choice state branches that don't do anything except stop running the state. Because succeed states are terminal states, they don't have a next field and don't need an end field. A pass state passes its input to its output without performing work. Pass states are useful when constructing and debugging state machines. This example shows a state machine that consists of a single pass state. When this state machine runs, it injects some fixed data, which might be useful for testing purposes. A wait state delays the state machine from continuing for a specified time. You can choose either a relative time specified in seconds from when the state begins, or an absolute end time, which is specified as a timestamp. In this example, the wait state introduces a 10-second delay into the state machine. The parallel state creates parallel branches in your state machine. A parallel state causes step functions to run each branch, starting with the state named in the branch's start at field as concurrently as possible. The service waits until all branches reach a terminal state before processing the parallel state's next field. A branch can fail because of an unhandled error or by transitioning to a fail state. If a branch fails for either reason, the entire parallel state is considered to have failed, and all of its branches are stopped. You can use the map state to run the same set of steps for multiple elements in an input array. The iterator field is required. This field's value is a reference path that identifies where in the effective input the array field is found. In this slide's example, the iterator is the input path field. Let's look at some key takeaways from this section of the module. Individual states can make decisions based on their input, perform actions, and pass and manipulate output to other states. Add branching logic to a state machine by adding a choice state. Run multiple functions concurrently by using the parallel state. Succeed and fail states do not require an end field. Thanks for watching and see you in the next video.